Okay, so the intent of this video is to demonstrate the lung protective nature of APRV versus conventional ventilation. This morning we're going to contrast APRV with pressure control, assist control, and we're going to be using a I time of 0.5, a respiratory rate of 30, a PIP of 30, and a PEEP of 8. Now this is our set of our test lungs. This is, you can tell by all the red coloration, the deep dark red, that's all atelectasis. That means that lung is completely collapsed. So we need to recruit it. And we're gonna start that with the pressure control, assist control, that PIP of 30, PEEP of 8, a rate of 30. Now you can see as the lung turns white there, that's lung being recruited. See how you get those patches of white? That's recruited lung. But notice how it deflates. With each breath, it still de-recruits or returns to a atelectatic state. So even with that PEEP of 8, we're not really holding that recruitment. And if you look deep down into the bottom there of your screen, you'll see that we're not even hitting the bottom part of that lung right now. But you can see slight changes in color. You're starting to see some recruitment there. That's actually what a fully recruited piece of lung looks like. And you see over time, it is grasping, it is taking hold, it is maintaining. That PEEP is starting to hold some of that lung open. But what I want you to notice is the violence at which it inflates and then rapidly deflates. Inflates, rapidly deflates. The problem with this is where, with the open lung concept, is trying to defeat. This is all shearing of the lung. Every time we do that, we are causing trauma to the lungs. So now in contrast to that, I'm gonna flip the APRV and I'm gonna actually cut the P high to 20, so 10 less than our peak inspiratory pressure now. So I'm going to deliver less pressure overall, but I'm going to leave it on a rate consistent for a rate of 30. Now watch what happens. See how that lung opens right up, completely inflates. Look at even that bottom lung that was so deflated on the bottom. Immediately we get that. So all that lung is now recruited and being held open. And now you can see those little deflections down. That's our exhalation. That is where we get our bulk ventilation from. But see how less violent it appears, because all that lung is being splinted open. It's being held open and gas exchange is occurring. Now again, that's on the same rate of 30. That's on, that's on a P high of 30. So let's turn the P high to 20. So in effect, this is our peak inspiratory pressure of 20 now versus 30. Even so, not that huge of a difference as far as shearing goes. That lung stays open and we don't see any of that de-recruitment, that red patchiness that occurs when the lung goes back down. So let's take it even further. Let's take it down to 15, a P high of 15. So now we're half of our PIP from our conventional ventilation. Half. And look at how still well recruited we are. That lung is completely open. And we're exchanging gas, completely recruited. So now let's switch back to conventional ventilation and watch what happens. We're going to go back to our peak inspiratory pressure of 30, our PEEP of 8, our rate of 30, and our I time of 0.5. Immediately, look at how we deflate. Look at how far it goes down. Yes, that is a product of having only a PEEP of 8. Our mean airway pressure is obviously lower than when we had our P high of 15, which was generating higher mean airway pressures. But look at how much more violent that is. And every breath we're de-recruiting. Now again, this is a crude experiment, but it does drive home the point that APRV is a much less violent, therefore a more lung protective mode of ventilation.